Hello, everyone, and welcome to today's webinar. My name is Peggy Imonyevu, and I'll be your moderator for today. This webinar is brought to you by Farm Access Foundation with support from Novartis. If this is your first time of joining us, we still welcome and hope you stick with us for subsequent webinars. If you're a returning guest, we still welcome back and thank you for being with us all the way. So before we start today's webinar, let's set some house rules. By default, when you come in, your mic will be put on mute. We ask that you keep it muted throughout the webinar so that there will be no interference in the background. Because we have panelists and participants join us from all over the world, we may encounter some technical hitches. We apologize ahead, but we'll do our best to make sure this is as smooth sailing as possible. We have times allotted for question and answer. If you have any questions for our panelists, please put them in the Q&A panel as against the chat panel. Now to the webinar proper. We have industry greats speaking for us today. Our first speaker is Dr. Greg Okwuobo, who is a public health physician and an epidemiologist. He is currently the head of the Special Statistics Unit at the University of Benin Teaching Hospital. Dr. Greg is passionate about using data for quality improvement in the health space. I like to call him the numbers man. He's joining us today from Finland, where he's currently pursuing a PhD in epidemiology. Our second speaker is Professor Tobias, who is a research director at Farm Access Foundation. He is a public health specialist and holds a PhD in molecular biology. Professor Tobias has a number of titles to his name, but some of his great works till these days include publishing over 225 publications in peer review, and he holds a chair at the Amsterdam University and the University of Leeds. So I'll be handing over to Dr. Greg now so he can start off. Over to you, Dr. Greg.
Thank you very much, Peggy, and thank you everyone for having me here today. I'm going to speak today on COVID-19, facts and fiction. Sounds like a science fiction presentation, but this is real because we are facing a real threat today. So I'll begin by using this outline, and which probably I have coined the truth meter. So today we want to see what is the truth and what is false, and do some fact checking on some of the myths and assumptions we have about COVID-19. So as the coronavirus disease spread, so is misinformation. And knowing the fact is key to being properly prepared and protecting yourself and your loved ones against this virus. So COVID-19, though, is spreading, but we must also say that misinformation is spreading as much as the infection. And today, we want to take a deeper look at this misinformation and see if we can till out some truth. COVID-19 is a disease. It is new. It is caused by a virus, SARS-CoV-2. The virus, as we know till date, originated from Wuhan in China. And on the 11th of March this year, the World Health Organization characterized the spread of COVID-19 as a pandemic that will require international efforts to control. So why are we interested in facts and fiction? Why the truth meter on COVID-19? The reason is simply because we are facing a real global threat. And last year, the World Health Organization listed 10 scenarios or 10 entities that may pose a global threat and probably threaten the extinction of our species. And number 3 in that list is global influenza pandemic. And today we are witnessing a realization of one of those threats. And another aspect of it is to also know that, currently it's an evolving disease, and a lot of things are happening rapidly. So there are few very reliable scientific evidence here and there. So the absence of evidence in this situation is not the evidence of absence. There are some things that we really do know. In addition to that, the global burden of COVID-19 is increasing daily. As at 20th July of this year, we have well over 14.5 million new cases of coronavirus worldwide. And sadly, we've lost up to 608,000 people. And well, we must still say that about 9 million people have recovered, but this is a real scenario. This is killing people, and there is need for us to take it seriously. And every country in the world as of today is infected. Another reason why we may wish to take it more seriously is that COVID-19 is posing an economic burden. And the World Bank in June of this year projected that the global economy is likely to shrink by 5.2% in its GDP. And that actually will tilt so many countries into recession and also tilt about 547 million people into poverty, with about 71 to 100 million into extreme poverty. If you lay that on the background of the already existing poverty situation in the world, achieving the Sustainable Development Goals in 2030 may as well be a mirage. Okay. Yeah, next slide, please. Yeah. So there are drivers of these facts and fiction. The misinformation doesn't just occur on its own. And some of the drivers I've highlighted here. The most important of this driver is the novelty of the SARS-CoV-2 virus. This is a brand new disease condition. Yes, we have knowledge of the coronaviruses, but this particular member of the coronavirus is quite new. So that is bringing a lot of speculations and therefore driving the fictions and the rumors. Then there is need to act by governments because people are actually dying and governments feel obligated to act, and such they are willing to act based on any information that they have. And we also have a very large asymptomatic group which goes to lay more doubt as to whether the disease is even real. The other aspect to it is the flip-flopping scientific evidence we've had. At a time, we heard we shouldn't use masks, facial masks. At another time, we heard we should. And these are very conflicting information. At a time, we heard we should use hydrochloroquine. At another time, we shouldn't. So all these are also laying credence to rumors and also misinformation. Then there is a general ignorance pervading in our societies, not just with respect to COVID-19, but with respect to how things work, with respect to how knowledge is generated. So the scientific evidence is not well understood. The process of generating scientific evidence is not well understood by the majority of the people. And this is one of the major reasons why we see a lot of misinformation. Then ideologies, whether political, religious, cultural, are also fueling the misinformation and the rumors and fictions. Then there is the real threat of science fiction. Some films in the past like Outbreak, films like Contagion have really painted a scenario for most people, and they just picture the COVID-19 case with those scenarios and come up with fictions and rumors. Finally, we also look at communication. Social media, everybody is now ideally a publisher because of the internet and the social media generation that we are in currently. So this is also helping to fuel the misinformation. In addition to the inconsistency in messaging, there are different groups, different bodies coming up and publishing different information. So all this is driving this misinformation. Lastly, we must say that we shouldn't rule out the role of global politics, geopolitics, accusations of countries not reporting cases, mistrust among countries. All this is adding to fueling the misinformation. So that is why it's important today that we look at specific aspects of this misinformation and put it through the truth meter. So what are our sources? Upon what are we looking at this different information? We are basing it on scientific evidence, the most recent scientific evidence, as especially those that are published in peer-reviewed journals. We're also looking at very credible authorities and organizations in health, like the World Health Organization, the Center for Disease Control and Prevention in Atlanta. They also publish facts, scientific evidence too. The Harvard Health, and many other organizations, as well as very credible ministries of health in countries. And then in some very few instances, some of this truth meter is based on what is known about the epidemiology of coronaviruses and also how they are prevented. So we're going to look at these truths and these fictions using the epidemiological triad. So at first we'll look at the agent itself, the SARS-CoV-2, then we'll look at the environment and then the host. So let's go with the first myth and the first, yes, and this is the first myth that is out there. COVID-19 is genetically modified as a bioweapon. This is very, very common in the social media space. But I want to say today that this is false. In fact, it is fiction. So we know what is causing COVID-19. It is SARS-CoV-2. It's a beta coronavirus. And then we also know the genetic sequence. China has shared that with the world. And many other researchers have also sequenced it. And the whole genome analysis of SARS-CoV-2 has been done. And there are very clear evidence that it could have come from the reservoir could have been the bats, but the intermediate host is still being debated. Currently, the pangolin animal is still being considered the intermediate host, but we do know that SARS-CoV-2 is a coronavirus and is of the family of the beta coronaviruses. So this is false. So the second one, this is just trying to further explain the family tree of the coronavirus, which is showing the different family groups of the coronavirus, and that is the alpha, beta, delta, and gamma. Down the line, Professor Tobias will shed more light on this. So the second myth that we would like to entertain today is COVID-19 is mutating, and this is a fact. This is true. The earlier variant of SARS-CoV-2 is the D614 variant, but recent evidence have shown that this variant is actually more prevalent in Asia, specifically in China. But for the rest of the world, what we are having now is the G614 variant, and more common in the US and in Europe. And what we've noticed is that the G614 is mutating in the spike protein. If you, Professor Tobias, we look at the structure of the SARS-CoV-2 later in the discussion. So, but a more threatening aspect of this is that the virus doesn't want to be lethal. It just wants to be more transmissible. So this is a virus that really don't want to cause any fatality, but it just wants to keep on living by modifying itself to be transmissible from one person to another. So this is important because it will help us in knowing how to develop immunological interventions. So the third one is the US has developed a vaccine for COVID-19. Indeed, the whole world is waiting for a vaccine because this will really help in preventing the transmission of the coronavirus, SARS-CoV-2. But as of today, there is no vaccine available, so this is fiction, it is false. But we have promising vaccine. What is happening in the US currently is there's a biotech firm called the Moderna, and as at last week, there is news that they are going into the stage 3 of the clinical trial to see how effective or the vaccine is. As at last week, we have almost 205 vaccine candidates or candidate vaccines in different stages of different trials, both pre-clinical and clinical. But the ones that are being tried in humans now is just roughly in the region of 21. Professor Tobias too will speak more. We also have vaccine from the Oxford trial also coming up and promising. But Prof will dwell more on this as we look into vaccine down the discussion. So like I said, these are some of the promising vaccines that we have. And up there is the University of Oxford vaccine that's from the AstraZeneca trial going on. It's almost in stage 2, moving to stage 3. And this is a listing of the other vaccines or the candidate vaccines that we are entertaining. And this is good news for the world. We are expecting within 12, 18 months, we should have probably a vaccine if everything is going according to plan. Okay. So we jump now to the environment. What about the environment that we need to know? What are the rumors and the myths? The first there is COVID-19 do not survive in tropical climates. And this is actually being peddled more in Africa and other tropical climate regions of the world. But sadly, this is fiction, it is false. And what we have found out that no matter how sunny or hot the weather is, which is a little bit different from climate, but no matter how hot or sunny the weather is, COVID-19 can still be transmitted. And countries with hot weather have reported cases of COVID-19. So, and just to add another layer to it, exposure to the sun. So deliberately exposing yourself to the sun or temperatures higher than 25 degrees does not protect against COVID-19. There is no evidence to support this as at today. So these are all still fiction. And also, this is another one. Prolonged use of face masks leads to CO2 intoxication. This is fiction. This is false. The evidence is not showing this. The prolonged use of medical masks, we know, may be uncomfortable, really. And whether it is the cloth masks or even the surgical masks or more detailed, the N95 mask or respirator, they may be very uncomfortable, but there is no evidence to show that this will lead to CO2 intoxication or oxygen deficiency. COVID-19 is not transmitted through houseflies nor mosquitoes. This is a fact. There is no evidence to date that, that suggests that the COVID-19 virus is transmitted through the housefly or the mosquito, which is actually good news for the mosquito belts in the world. So that, and for me, this is actually a personal relief because I live in the mosquito belt regions of the world. So, but evidence has not shown that the virus can be transmitted by mosquito. COVID-19 spread primarily through droplets generated when infected persons cough, sneeze, or speak, and we cannot stress this enough. This is how it's spread, and this is why we encourage all the prevention or preventive measures that we put out there. Yes, this is the one that got most attention globally. 5G mobile network do not spread COVID-19. This is a fact. It doesn't. Viruses, basically, this is just basic stuff. Viruses cannot travel on radio waves or mobile networks. This is known. And then 5G radio waves, if you want to look at it more microscopically, is non-ionizing. What that simply means is that it does not damage DNA inside cells. So it is in the region of the light spectrum that has very low wavelengths, and as such, it doesn't really cause any damage to the DNA inside our cells of our body. So COVID-19 is even spreading in countries that do not even have 5G. So this is another addition to the fact that this is not being propagated by the 5G mobile. Don't forget, we have earlier radio waves used for mobile data transmission, like the 4G and the 3G. So 5G is just a higher technology added to that. So these are radio waves and they don't. And just to go through the scientific evidence down there is no, this is from the Public Health in England, there is no convincing evidence that exposure below the International Commission on Non-Ionizing Radiation guidelines can cause adverse health effects. These guidelines go up to 300 gigahertz, whereas the maximum for 5G will probably only be in the tens of gigahertz. So this is a publication from the Public Health of England, and this is actually what it is. So this is a fact: 5G cannot transmit COVID-19. Children can transmit the new coronavirus to other people. This is a little bit of half-truth. It's half true, and this is part of this is the area that is receiving a very active scientific research as at present. And just before this webinar started, there is a publication that came out today from Harvard Health that actually revealed that children less than 10 years old transmit the virus far less compared to adults. However, children 10 to 19 years, which probably that's the adolescent age group, transmit the virus or spread the virus at the same rate as adults. So if you play that into the scenario, children 10 to 19 years may be part of the active of spreading this disease. That is why there is still hesitation in opening schools now, because these are research that are highly powered using very large sample size. So children really could be part of the transmission, but at a very minimal level. Pets can spread the virus. Yes, for the pet lovers currently in this webinar, this is maybe important to you, and this is a fact. But this fact is still under serious investigation. That is why we rated it half true. That's because the evidence has shown that a small number of pets worldwide, including cats and dogs, have been reported to be infected with the virus that causes COVID-19, mostly after close contact with people with COVID-19. So based on the limited information available today, the risk of animals spreading COVID-19 to people is considered to be low. So it's considered to be low. So the advice here, what is being advocated, is that pets should be treated the way we would treat other human family members. So if you are infected or you are in self-isolation, you need to also self-isolate from your pets, not just from humans. The next is COVID-19 can spread through airborne transmission. This is also half true. And that's because the World Health Organization has acknowledged that there is emerging evidence that the coronavirus can be spread by tiny particles suspended in the air. At this point, I would like us to know that there is a difference between droplets transmission and airborne transmission. And the difference actually is in the particulate size. So we need to know, and this is coming out from the World Health Organization this month, that there is evidence to show that there may be a possibility that airborne transmission is possible, maybe. So this is half true, and this is an area of active research currently. Africa has low incidence of COVID-19 because it is mainly tropical and has a young population. Well, this is really very uncertain, and at best, we can put it in the fiction realm. And we will allow time to tell if this is true. But what is known is that COVID-19 is a pandemic spreading to countries of all climate zones. And there is a study that looked at 19 provinces in China, both dry to tropical climate. And it showed that in all of the climate or conditions, there is a sustained COVID-19 spread. So, and even in Singapore, one of the earliest countries to report COVID-19, which also lies near the equator, there is also a report that more than 250 COVID-19 cases of community spread within this, and that's also within the same tropical region like Africa. But I think the most important evidence is the fact that a month ago, you may not have, if you are following the trend in the confirmed cases, the top 10 countries, you may not see a country from Africa. But as of today, African countries are making it to the top 10, which means there is active community spread. South Africa, as at today, is the 5th country with the highest confirmed number of cases. So that still goes to show that, yes, it can spread, and our young population may not necessarily be protecting us. BCG vaccine protect from severe COVID-19. This is still uncertain, but we are tending toward fact because evidence from studies done have shown a consistent association between BCG vaccination and reduced severity of COVID-19. But the catch here is that the evidence is not sufficient to establish causality between BCG vaccination and protection from severe COVID-19. But signals of BCG vaccination effect on COVID-19 mortality are also influenced by social, economic, and demographic differences between countries. It may not necessarily be that it is the BCG vaccination. It may be other confounding factors. Then let's look at the hosts, the humans. What are the myths, fictions, facts? People of all ages can be infected by the COVID-19 virus. This is a fact, and this is mostly true. Everybody is at risk. 2, we are going to get the virus anyway. There is no point in taking drastic measures. This is fiction, because if you don't handle it properly, our health capacity may be overwhelmed, and that is when the real pandemic probably may be in place. We are going to, now the next one is COVID-19 only kills the elderly. This is false. Evidence have shown that younger people also die from COVID-19, even those without comorbidities or pre-existing condition. Everyone who has COVID-19 has same symptoms. This is fiction. We've seen different symptoms presenting, but the commonest symptom is fever, cough, and even sometimes some may have headaches, sore throats, their respiratory difficulties. So people can present with different symptoms, including others that are specific to some organs in the body. Loss of smell and taste are symptoms of COVID-19. This is a fact. A huge evidence has shown, convincing evidence that people that are infected are presenting with loss of smell and in most instances also loss of taste. There are currently no drugs licensed for the treatment or prevention of COVID-19. Well, we'll give this half true because yes, there's actually no licensed treatment for the disease called COVID-19, but there are treatments for specific symptoms. So that's why this is giving half truth. And there are efforts to search for a lasting treatment. COVID-19 is a vascular disease. This is uncertain, but evidence is showing that though the coronavirus is a respiratory virus, but a major aspect of the effects in the body is vascular diseases and vascular clinical features. And there is mounting evidence that there is vascular damage, and sometimes within the lungs there are new growths of vessels, which actually probably may be a compensatory mechanism to the damaged blood vessels. So the effect is showing vascular disease, but we should not forget that the coronavirus is a respiratory virus. Going to the hospital will increase your risk of having COVID-19. This is half true. And the reason why we are putting it there is because, yes, nosocomial infections can spread in the hospital, especially those that have very poor precautions and infection control protocols and practices. But that does not mean that visiting the hospital will automatically lead to having COVID-19, because there is still other services provided in the hospital, immunization services, maternal and child services, and treatment of other conditions. So if you need to go to the hospital, then you have to. People should not wear masks while exercising. This is a fact, and this is mostly true. If you are exercising, masks may compromise the oxygen and energy interplay in the course of exercising, and most times the mask may become damp, and that will probably lead to hastening spread of the disease, of the virus. So what it encourages is that when exercising, you may or you can remove the mask, but you maintain other social distancing protocols, give a space of at least 1 meter from the next person while exercising, and as soon as you are done with exercising, put on the mask again. Eating garlic, Madagascar remedy, vitamin C, and antibiotics can treat or prevent COVID-19. This is still in the realm of fiction and is largely false. Remember that scientific evidence is the key here, and most of these products or vitamins have not gone through rigorous scientific evidence to show that they are actually useful in the treatment of COVID-19. Patient developed immunity after recovering from COVID-19. Well, this is still very, this is uncertain, and we are not sure yet. And the reason for this is because we've noticed that that those who recovered from COVID-19, only about 14% develop immunity against a second infection, just 14%. And largely, within some few months, this same individual lose this immunity. So there are still very huge research in this area, and even the research is being hampered by the fact that measuring antibody titer in the blood is not too perfectly done right now. So all this is that's why this is still in the not sure, uncertain region. There is possibility of reinfection after an episode of COVID-19. Yes, this is mostly true, and this is also an extension of the earlier facts. And this is because right now we are not sure that there is immunity after a first episode, so there's possibility for reinfection. Most patients die with COVID-19 and not of COVID-19. Well, this is what the facts said from what WHO is putting out. Most individuals who had one or a combination of underlying conditions like cardiovascular disease, 66% of them have it, diabetes 29%, and renal disease 12%. So you could actually say that most people are dying with COVID-19 and not really of COVID-19 if you look at that statistics from WHO, because it probably may be that is the comorbid conditions that are killing them. They just happen to have COVID-19 because the coronavirus infection because of their compromised immunity. However, we also know that 1/10 of all COVID-19 deaths, especially in England and Wales in March and April, had no pre-existing health condition. So some people may be dying of COVID-19, 1 in 10. So this is mostly true. COVID-19 is an avenue to chip us all and create a new world order. Yes, this is actually coming straight from science fiction. This is largely false. This is not science fiction or films or movies and all that. There is no evidence whatsoever to support this. Yes, and then this is very common now. Bill Gates has created a new coronavirus to control the world and is creating a vaccine for it. This is also fiction. This is false. But where this is coming from is the claim that refer to a patent application for a coronavirus filed by the Pelbright Institute. I must say that this institute wasn't or is not founded by Bill Gates. It just happened to be that Bill Gates, being the philanthropist that he is, funds or as one of the founders of this particular institute. So, and more so, the vaccine by the institute is largely for birds and other animals. So it's instructive for us to know that the vaccine that has been patented by this institute is largely for birds and animals and not for humans. So now, let's now go to the sources for scientific evidence on COVID-19, because there are so many out there, but these are important ones. And if you really want to fact check, please go to the WHO Mythbusters. CDC Atlanta also have a link where you can go. There are national ministries of health that are credible and can provide reliable source of information and valid source of information for you. Peer-reviewed journals, there are special COVID-19 editions in the very high impact ones. Lancet has, New England Journal of Medicine has, and so on. Then there is this website, the Full Fact Great Britain website. This is a very good website where you can get the latest information and fact checking of all information that you may have on COVID-19. I've included the last one, Coronavirus Fact Checker. This is more like an infotainment blog. It may be specific to Africa, because it's not just about the agents and also the environment and the host. Sometimes you may need to find out socio-cultural misinformation and fiction. So what's our responsibility as individuals, citizens of the world, or healthcare workers? The first thing is that we should be open enough to accept empirical truth, but not too open enough that our brains fall out. This is a quote from Carl Sagan. So we should be open, we should examine all truth, and then we should deliberately seek scientific evidence from credible sources. And not just that, we should triangulate information and act with it. And if there is no scientific evidence existing, then we have to rely on known epidemiological models and common sense. So in conclusion, everyone listening, I would like to say that COVID-19 is a disease, and we know that it is caused by the new virus, SARS-CoV-2. Our understanding of COVID-19 is changing extremely rapidly, and new findings come out daily. Whether facts or fiction, we have a responsibility to act with informed decision to secure our public health. So I want to say thank you, everyone, for having me here today. Thank you.
All right, thank you so much, Dr. Greg. Interesting background you have there between. I don't know if you'd like to go over the answers to the polls. So we'll see whether people already knew what you were going to teach them about, or if our knowledge of the COVID-19 is very far from the reality at the moment.
Thank you, Peggy. Yes, this is quite interesting and very revealing. Yes, we put out this at the beginning, and this is the responses. People of all ages can be infected by COVID-19. Gladly, 93% says yes. We are going to get the virus anyway. There is no point in taking drastic measures. This is people's 84% says false. This is huge, but I'm more worried about the 8% that says mostly true and true. I'm more worried about that. I hope this presentation has helped with that. COVID-19 only kills the elderly, false, 90%, but I'm still worried about the 10% that says true or mostly true. Loss of smell and taste are symptoms of COVID-19. 83% says true, and that is very nice. There are currently no drug licensed for the treatment or prevention of COVID-19. 76% said true. I am more than impressed. Going to the hospital will increase your risk of having COVID-19. Yes, there is a bit of doubt in almost everybody's mind here, which is exactly what we expected. It's a 50-50 response, and it's also playing out. But like we said, yes, you may have nosocomial, but we still need the hospitals for other conditions. People should not wear masks while exercising, another area of contention, and it is playing out. 34% says true, while 41% said false, but it is mostly true, really. Eating garlic and the rest of them, Madagascar remedy, 66% says false, yes. And they cannot, and I'm really, and then of course, I'm happy with the uncertainty here, 27%, and that is why we are having this webinar. So it is actually false. There is possibility of reinfection after the episode of COVID-19. True is 56%, 29% of certain, 13% mostly true. Well, you already have it today, and we are not sure yet. We are still in the uncertain realm, and there is a lot of research going. Then lastly, COVID-19 is an avenue to chip us all and create a new world order. I am more fascinated by the 16% that says true and the 7% that says mostly true. This is very, very interesting, but like you have it today, this is false. The truth meter says it is false. There is no chipping anybody. And thank you all for participating.
Thank you, Dr. Greg. Please stick around. There are a number of questions waiting for you at the moment. And let me just use this opportunity again to remind everyone to please post your answers in the Q&A panel as against the chat panel. Because when it's in the chat, the possibility that it would get missed or overlooked is very high. So at this moment, we'll hand over to Professor Tobias, who will be taking us on the updates of the COVID-19 virus. Professor Tobias, please.
Thank you very much, Peggy. It's a pleasure, as usual, to be here. I realize I have 15 minutes, right? So what I would propose is I have a big presentation. We share the presentation with anybody who's interested, and I'll take some highlights from it now, if that's all right with everybody. Okay. Thank you, by the way. It was an excellent pre-presentation here, and a lot of facts and fictions already have been solved. We know basically that we talk about a virus that is a very complex virus. It has a life cycle. We're not going to go into the details of it, but I want you as a take-home message to understand that this virus contains many, many, many genes, open reading frames as they call it, and it is complex. It is 30,000 bases long, so it's 3 times bigger than HIV, and it can do all kinds of interesting things. In other words, this is not a simple disease with a simple virus, it is complex, and I'll come back to that. As was explained already, there are 4 different types of coronaviruses: alpha, beta, gamma, and delta. And COVID is a member of the beta viruses of corona. Basically, there are, at the moment, as far as we know, 7 human coronaviruses known. 4 of them are quite not dangerous at all. They're old viruses. They have been with us for many, many years. They usually cause upper respiratory tract infections, and that's it. Simple flus like you see with children and so on. The 3 dangerous ones are MERS, SARS, and SARS-CoV-2, COVID. These are new viruses. They cause upper and lower respiratory tract infections, and they can end up, like you see here, in crucial situations in hospitals. What I also wanted to tell you, not only the virus is changing and difficult and complex, the receptor for the virus as well. The receptor, which is called ACE2, it's on a cell here. As you can see, the virus is binding to the ACE2 receptor using its spike protein. And there's an S1 and an S2 area of the spike protein. The S1 area binds to the receptor, and the S2 takes care of the fusion of the virus with the cell. And if you look at the ACE receptor in the world, many of those receptors have been sequenced and identified now. And we're not going to go into the details, but look at all those different colors and all those different ratios of those viruses in different parts of the world. In other words, ACE2 is different in many places in the world. So it means also that the infectivity of the virus which is dependent on the receptor, on ACE2, can be different. So we're not only talking about a complex virus, we're also talking about a complex receptor. And the interaction between those two is even more complex, as you can imagine. This was already discussed, mutations that take place in the SARS-CoV-2 viruses, which can lead to more dangerous forms. Here's an example of the D to G mutation. In January 2020, on this position 614, it was mostly D. But over time, as you can see, the dates move. In May, the D was replaced by the G, like in Europe. It's the D614G mutation. And this mutation leads to the fact that the virus has suddenly 5 times more spike proteins on its surface. And the more spike proteins it has, the better it can infect another cell. So it looks indeed like the virus is mutating into a more adapted form, which can even more efficiently infect human beings. So indeed, evidence for mutations. And there's a whole database, and you can click on this link and then you can get all the details how viruses are mutating. Not going to go into the details now. You get the PowerPoint if you like, and you can click on it and see. Some things about transmission. We all know that eventually these types of viruses are because of human behavior. The viruses, they are originally in wild animals, and if human beings would not be so aggressive, and if we would not destroy the environment and cut down the forests, then we might not be so much in contact with all those strange animals. If we would not eat those animals, we would not have all those exposures. So it is a lot of human behavior that plays a role. Here is the pangolin that already was discussed previously by Doc. So the pangolin is most likely the host in this case. People eat pangolins in China, and it is very likely that the virus from a bat jumped to the pangolin and jumped to human beings. Here's Salim, our prof in South Africa, talking about the first case. This was the COVID conference last week at the end of the International AIDS conference. And he was talking about the first patient who was identified on November 17, 2019, a person of 55 years old. And can you imagine that in a couple of months' time, this moved over to more than almost 200 countries in the world. A couple of important observations. Shedding of the virus, which means that the virus is released from the body of an infected person by coughing, by talking, by sneezing. We see that many people start to shed those viruses 1 to sometimes 3 days before they get symptomatic, if they get symptomatic at all. And there's quite some communication now that a lot of new infections with the virus in fact originate from asymptomatic patients. In other words, the people don't know that they're infected. And then during this phase, they already infect other people. And this tells you also how clever the virus is in a way, by jumping from one person to the other, because of hiding away its symptoms a couple of days later than that it is really already shedding from one person to the other. Of course, the virus cannot think, but by mutation and selection, these types of viruses are more efficient, so they are getting selected. Another important thing about shedding is that we found recently that these asymptomatic people who have no symptoms, have longer duration of viral shedding. You can see that here in the light blue. If we look at the number of days, the duration of shedding, you can see that on the average, asymptomatic people have longer shedding time periods than symptomatic people. The average, even the median, is 19 days, which means that people who are infected with COVID, they can, and who don't have any symptoms, can for 19 days continue spreading the virus to other people. Of course, we don't know yet how infectious those shed viruses are, but the principle, I think, is very clear. We should be careful that asymptomatic infections definitely play a very important role in transmission. As was already explained, airborne transmission is the most important transmission route, and there are 2 different airdrops. There are the big drops, and when you talk, that fall to the floor and to surfaces, and then through those surfaces can also infect other people, like doorknobs or chairs or buttons of the elevator or a staircase helps. And there are the aerosols, the small drops which remain in the air, which can be breathed in. And both of them play a role. However, we don't know exactly which one is more important than the other. The current opinion, at least in Europe, is that the big droplets are more important than the aerosols, but this is an area of active research. Here you can see the droplets and the sizes of those droplets. I'm not going to go into the details. It is very clear that if we talk about small and big droplets, then masks remain very important for protection, obviously. Another thing is also very interesting. If you talk about aerosols, then ventilation is very important. If you talk about the big droplets, then the 1.5 meter distance is important. If you talk about the small droplets, then which remain in the air, sometimes for hours, then ventilation is important. And here we see a nice example of a Chinese restaurant where there are tables and people sitting behind those tables. And in these 3 tables on the top, there were quite some patients who infected each other. And they did so because there was poor ventilation, and therefore the virus could linger on in the air, in those aerosols for a long time, and probably has infected so many people around those tables, while other people were not infected. Evidence for aerosol transmission. Another question is, there is quite a lot of viruses in stool of human beings, even more than in respiratory areas. So to what extent does this play a role? Well, up to now, there are no reports on transmission from feces to human beings. So it looks like there are viruses in stool, but they don't transmit up to now. Vertical transmission, transmission from a pregnant woman to a child who's in the womb. It is possible, but it is very rare. There are some papers on it, you can look it up. And honestly, when the newborns are there, they don't have serious symptoms. So it doesn't look like something very, very serious, but it can happen. Okay, a couple of clinical things. Here we see Tony Fauci, who presented on this during the International AIDS Conference also last week. We know about the median incubation period, 4 to 5 days. 4 to 5 days after infection, you might get your first symptoms. But of course, a lot of people don't get symptoms at all. Well, we have already discussed the symptoms like fever and cough and so on. What I think is very interesting, I'll tell you later about that, is the loss of taste and smell and what can be the consequence of that. Most of the people have very mild and moderate symptoms, and only 5% have critical symptoms. We know that. We also know that people who have all kinds of underlying diseases have an increased risk of getting into trouble with COVID. This is all very well known and described. In this slide, I just wanted to tell you very simply that the disease has 2 big stages. If you look in time, in the first 1 or 2 weeks, the viruses are the most important. In other words, the COVID viruses, they start infecting you, they start creating damage and so on. But in the later stage of disease, let's say week 3 and week 4, the host immune system response becomes more important. And if the immune system makes mistakes, then we get into serious trouble and create more and more disease patterns. So it is basically a 2-step disease with viruses as well as inflammation, which means that if you want to develop drugs against the virus, they should work against viruses, but also against overactive immune systems. And these are totally different types of drugs. Because it is a complex virus, it gives complex diseases, it gives kidney damage. I'm not going to go into the details, you can look it up. It gives unusual blood clotting with the risk of stroke and the risk of thrombosis. It creates vascular leakages, so leakages in your lungs of your veins. It creates also, and I wanted to give you 1 minute on that, so-called olfactory and gustatory dysfunctions. So you don't taste and you don't smell. In Europe, a big study was just recently done on this. 86% of the people in Europe had some kind of smell or taste dysfunction because of COVID. And how does that work? There's a nice picture on this. Basically, we have in our nose, in the top of that, we have the so-called olfactory nerves, and they connect directly to the olfactory bulb in our brain. And those nerves, they are open. And why is that? They are in open and direct contact with air. And why is that? Because human beings have to smell very quickly that something is wrong and then react. For example, they have to smell that there's fire, so they can run. Or they have to smell that there's some food which is poisonous, so they don't eat it. So these are very quick reaction trajectories. And therefore, the nerves are open. But that's also the direct entry point of COVID into your brain. It's the only place where the virus can directly enter your brain through those nerves. And what we see indeed is that there are brain-related COVID symptoms like headaches, nausea, vomiting, confusion. We see that in 10–15% of the COVID patients. And we know also from the laboratory now that the virus can replicate in neural cell lines. So it is more complex than we thought. the virus can also get into your brain, and maybe even indirectly, it can interfere with your brain system that helps you breathe. So your breathing might also be influenced by the brain part of the infection. It's quite interesting biology. Another thing I found very interesting is that there is a clear relation between depression and lack of taste. People who have normal taste have less depression than people who have no taste. And that's logical in a way, because the mental health, when you don't taste anything, when you don't smell anything, somehow you feel unsafe. And if you feel unsafe, your mental health goes down. It's old biology. And we see now that the longer term effects of COVID on quite a lot of people is mental health problems in the longer run. I thought it was a very interesting biological phenomenon. I'm going to skip a lot of epidemiological stuff. You can look at that later. I just wanted to tell you there are reports that there's more COVID in men than in women. We know that, almost twice as much. Probably related to the fact that the receptor for COVID is on the X chromosome, which is the female chromosome. And also because we know now that sex hormones like estrogen and testosterone play a role in immune regulation, and therefore probably also in COVID. We also know there's a relation between ethnicity and COVID. Here are newspaper articles, but here's some more direct, real scientific evidence. Compared to white, non-Hispanic Americans, who have 46 out of 100,000 hospitalization rates in the United States, look at black people in the United States, 5 times higher. So there is a clear relation there also, probably also confounded by poverty status and so on. Herd immunity, this is my country, the Netherlands. What we need is a 60% herd immunity. 60% of the population should be immune before the virus is really stopped. Well, in my country, we failed to do that. It's definitely not there. In April this year, it was only 3%. In June this year, it was 5.5%. In July, it was 4.5%, already going down. And we see that in the whole world. Herd immunities, if you look at different countries, are low. There are 3%, 5%, 7%. They all are below 10%. In other words, immunity does not spread that easily in populations. I'm just now, it's 3 o'clock for you, 4 o'clock for me. I'm asking Peggy, can I still continue for another 5 minutes, or would you like me to stop here?
Yes, please. I think you can actually even take 10 at this point, because I've been getting private messages requesting for more time from you. So yes,
Okay.
by all means. Yeah.
Okay.
Thank
you so much, Peggy. I'll
You're
continue.
welcome.
All right, something on the world statistics. Well, we all know it was already presented. It's huge. We are at even more now than 14.2. We're at 14.6 million. It's all over the place. At the moment, it's mostly United States and South America, but things are moving quickly in Africa. And the big question now is, okay, Africa started later and slower, but the worrisome thing is that we might move up towards very high levels. There are, of course, reasons that Africa possibly is less well off, is less infected, because the people in Africa are younger, and young people have less symptoms or are not infected. And also we know that, people in Africa, they might have different immune reactions and immune systems. What we see at the moment is that the number of symptomatic patients in Africa is lower than in the United States or in Europe. There is something with the immune system in Africans that makes them a little bit less sensitive to the virus. They still get infected, but they have less symptoms. There's active research. I'm, by the way, doing research in this area. I'm happy to explain to people more in detail by email what that could be. At least we know the worldwide confirmed cases. The United States is basically going through a second wave already. You can see it in orange. It went up, it went down a bit, and now it's going up big time. And that's because, of course, excuse me, because there was a release of the house staying at home measures. Okay, I'm sorry about that. I'm gonna skip this one. Say something about drugs and vaccines. The most important results recently coming out are from the recovery trial, which is done in the UK. It's a huge trial, 12,000 people, 175 hospitals, and testing different drugs, antiretroviral drugs from HIV, dexamethasone, hydroxychloroquine, and 3 other drugs. In other words, it is a huge trial, and the first results are coming out now. We see that lopinavir-ritonavir, which is an HIV drug, basically does not work. There's no significant difference between the intervention and the control groups, and therefore forget about this recycled HIV drug. It's not going to work against COVID. Dexamethasone, you heard about it. It looks like it's doing something. It is an immune suppressor, and particularly it works in people who are quite sick, who are symptomatic, severe symptoms. Then dexamethasone is doing something. Basically, it reduces 1 in 3 in patients receiving invasive mechanical ventilation, the 28-day mortality. If we look at mortality, the mortality is reduced in 1 out of 3 very, very sick patients, which is a good sign. It's not a perfect drug. It does not really help everybody, but it does something. Hydroxychloroquine, the favorite drug of the President of the United States, does not work. First, small studies were done. Now this very big study is done in more than 1,500 people and 3,000 controls. And by June 4, just 1.5 months ago, the Independent Data Monitoring Committee of Recovery of this trial said, stop. We don't see any differences. It's not beneficial to people. Stop hydroxychloroquine evaluation. So the drug is basically obsolete for COVID. Remdesivir, it's originally a drug against Ebola. It was developed by Gilead. Also here we see some effects. We see that patients receiving the drug had a 32% faster time to recovery than controls, which is good. I mean, there is something. But all of these drugs, we have to keep in mind, are recycled existing drugs. They are not specifically developed for COVID. They have partial effects, but they don't have the real specific COVID effect. This is logical. When you are in a hurry, you first try to recycle existing drugs because they are easier to make. They are already tested. They are faster. And maybe sometimes their patents are already expired. The best, of course, would be to have a very specific drug against COVID, and a lot of work is being done on this, but not yet studied in big trials. Vaccine trials, well, we know that at least between 150 and 200 of them are ongoing. 20 to 25 are taking place in humans. And basically there are 4 types of vaccines that can be used. I think that's interesting to know. Either you use an attenuated virus, which basically means you use the real COVID, but you make it weak in whatever way. Not everybody likes that because, you know, would you like to be vaccinated with a weakened virus? Maybe it starts to mutate back towards a more virulent one. So there are risks for that. But there are trials done in China mostly with Sinovac in the area of attenuated viruses. Then the second option is to take a piece of the virus, for example, the spike protein, and build it into a harmless vector. And that is done in the current Oxford work that has been published yesterday. I'll show you one slide on it. That looks like a very promising approach. Then there is a third way, which is take the RNA of the virus and put it in a steroid coating and let it self-amplify, the Moderna trials. It's a possibility, more innovative, less tested, certainly promising, but not yet evaluated in detail. And the fourth way is, of course, to make proteins themselves, make a protein vaccine, which is a more established procedure. Now, the second way is done by Oxford University. I just wanted to tell you that my country, the Netherlands, has already purchased 300 million doses, together with 3 other European Union countries, Italy, I think, and Spain, and I thought Germany, I'm not completely sure. This shows you also what's happening worldwide. A big discrepancy between the haves and the have-nots. countries who have money, they already start to procure vaccines even before they already have been made. And that is an additional problem for the African situation. Africa is not going to do this and cannot do this. And also, what is very unjust, testing for COVID is expensive. And who are the first ones to buy those tests? Definitely not Africa. Africa is again at the end of the row. To me, I've been there in the early days of HIV. It looks like antiretrovirals. We cannot get diagnostics into Africa. They're all sold out, the far majority. The same was 20 years ago with antiretroviral drugs. They were too expensive and they were sold out. I find it a very worrisome development. Here's the Oxford trial. I just would like to show you the data of today. It was published yesterday, the Oxford vaccine. What they did is they gave 3 different doses to people. And the primary outcome was, were there any adverse events? And the longer term outcome was, do we see safety over 28 days after the vaccination? And also B-cell and T-cell immune responses were already tested. And basically the answer to this is, there were no serious adverse events. The vaccine showed to be pretty safe, very safe over 28 days. And yes, we do see B-cell and T-cell responses. For example, here we see a T-cell response day 14 compared to day 0. Well, there are clear interferon gamma producing T-cells. So definitely, even there's a dose-dependent response. You can see that with low doses, the response is a bit lower than with high doses. In other words, yes, the vaccine elicits immune responses. Great news. Diagnostics, I'm not going to go into much detail. I just want to show you, this is my last slide, on diagnostic testing, because diagnostic testing is so rare in Africa. PCR is expensive. There are only 1 or 2 or 3 central laboratories that can do it. We should move towards more rapid and more affordable testing, probably by serology. As you know, by time when somebody gets infected, then first the viral load will go up, the viruses will be there. You can measure the viruses by PCR. Then IgM and IgG antibodies will come up, and these can be tested by serology. The problem with serology, of course, is that not everybody makes antibodies, and particularly the asymptomatic patients, they might not make sufficient detectable antibodies. Antibodies don't last, they disappear over time again. After 2, 3, 4 months, you can sero-revert. That never happens for HIV. And with HIV, once you're seropositive, you're seropositive for life. For COVID, you can be seropositive, and after a couple of months, you become seronegative again. The other thing is, do serological assays really determine the right antibodies? Are these the neutralizing antibodies that kill the virus? That's not always the case. We don't know. So there are quite some challenges related to testing. Still, we should develop as soon as possible the $1 rapid test for COVID for Africa. Thank you very much for your time.
Right. Thank you, Professor Tobias, for that. I can tell you I'm happy at this point to be a woman, as my chances of being infected are rather slimmer than that of a man. Yeah, go women. Okay, so we have a number of questions and we'll just take them as they come. The first one here is directed at Dr. Greg, and someone here is surprised that with the ups and downs around the info on COVID, you can state with all certainty, without equivocation, about the actual nature of the virus. I mean, I think this person is questioning your guts with all that is going on COVID. How are you so certain that it originated from a certain place? Would you like to answer that?
Thank you very much. And I just want to let you know that it is very, very right for you to doubt. And those who are doubting are not crazy. And the fact that we, based on the gene sequencing and based on a very fine, detailed epidemiological tracing, we do know that it originated from Wuhan in China. That we do know. And we also know the genetic sequence. That we do know. Those are not new right now, and we can, like you've seen, the prof rightly detailed the genetic makeup and everything. That we know. So that area we are very well on it. What we don't know now is the intermediate host. There's still questions about, is it the pangolin animal? Is it another animal that is the intermediate host, and so on? But we know it's related to the bats, to the type you find in bats, especially the horseshoe bats. So we know all this. There's a lot of work done by both the animal health experts, the epidemiologists, the geneticists, microbiologists. A lot of experts have put their efforts and time into tracing the origin. So we do know the origin. So that is why the evidence is in favor of all of the assertions that I've made today.
Thank you. Professor Tobias, someone is asking here what the level of protection with the use of ordinary cloth mask is as against the surgical mask or the N95 mask.
Yeah, these are, I think surgical masks are one step too far. And for a normal citizen who goes to places, that's not necessary. They're also very expensive, and I would please keep the surgical masks for the surgeons. There are already shortages. Please, let's not use them as general public. The normal masks are more than fine.
Thank you. Dr. Greg, do you think using the old method of covering with a cloth over a pot of boiling herbs can help the COVID-19 patient?
That's very interesting. And you're asking the right person.
I know, yeah.
I'm from a very traditional home. And,
which is why I directed it to you.
And there is no evidence to support that modality. I want to reiterate, there is no treatment for the COVID-19 disease, but there are treatments for some of the symptoms. Doing this traditional covering of your head with a hot of water may be soothing at best. It can soothe some of the symptoms, make you feel better, and so on. So if it's recommended by your managing physician, please do go ahead. But no evidence to support that it's a candidate for a treatment modality. No evidence as of today.
All right, thank you. Professor Tobias, if you'd like to take this. This person wants to know the reasons why adolescents are more vulnerable to COVID-19 than the children.
Yeah, that's a good question. It is, in fact, a remarkable thing that young children are so much less susceptible to this virus. It most likely has to do with the development of the immune system since you were born and then over the years. And when you're born, your immune system is naive. It hasn't seen anything, and it develops over time. And what we see is that in younger children, the so-called innate immunity, which are the natural killer cells, are very strong. So let's say the majority of animals even only have innate immunity. This is immunity which is not built up, it's not specific, but it is something inherited. So what you see in young children is that natural killer cells are very strong. And natural killer cells are very efficient in killing COVID. So and over time, when you go into your adolescence, then your natural killer cells are going down and your normal adult immune system is going up. And your normal adult immune system somehow is less fit to fight this virus. So that could be the explanation.
So there's another question for you as well, Prof. Why is the idea of a vaccine the approach to corona cure?
Can you repeat the question, please?
Yeah, I will. Why is the idea of a vaccine the approach to the corona cure or the corona management? Why vaccine over?
Yeah, you know, there are about vaccines and about cure, about treatments. And the question is, what is better? Well, when I talk, and also what is the most promising? Let's say I'm an immunologist. From a vaccine point of view, vaccines will never work 100%. There is no vaccine in the world that is 100%. Yeah, like also with drugs. I'm personally a bit careful saying that vaccines will solve everything. Even the Oxford vaccine that was published yesterday, we have to keep in mind that antibodies, as we know, are disappearing from the body in a couple of months already. We see that in COVID patients. So the question is, how lasting is a vaccine? If you are vaccinated, will you be needing another vaccine 4 months later or 6 months later? Probably. We might have to go to a once per year or twice per year vaccination. Think of the logistics and think of the money to vaccinate 7 billion people, twice per year with a vaccine. Then also the virus is mutating. So the virus might mutate away from the vaccine over time, yeah, because you put pressure on it. So vaccines, they have logistical problems, they have financial problems, and they have immunological problems. Sure, they will save many, many lives. And of course, we should go for vaccines. But I'm not sure whether it is the ultimate total solution. It probably is a combination with drugs, and we need to develop specific medicines, not the recycled medicines, but specific medicines for the virus. That will take more time. That's difficult. It might take a couple of years even. So my answer to your question is, you should do both. Use vaccines and drugs in the right combinations.
All right, thank you. So another for you, Prof. What is the role of zinc in prophylactic care? Is it ideal for use?
Zinc. Yeah, there is a lot. There are many ideas about vitamins, minerals, food supplements to boost your immune system. Sure, it is always good to boost your immune system, okay, in general. There is no scientific evidence that those minerals or vitamins have any effect against COVID, to protect you. But in general, of course, you could imagine that when you're in a bit better condition, for sure, if you are not obese, if you do sports every day, and if you eat healthy, then your immune system will be better. That's logical. And then all in all, it might indeed fight the virus a bit better in the early stage. So, of course, my answer is, please, take care of yourself. Have a good health. Exercise, run, don't eat too much, eat healthy. That's good for, and it will prevent a lot of other diseases as well, not only COVID.
All right, thank you. So, Dr. Greg, hydrochloroquine is useful for treatment of COVID-19, fact or fiction?
Well, that's fiction, and the evidence is pointing to fiction. Prof has shown the very large study that was ongoing that had to stop because of many more people were dying in the hydroxychloroquine arm compared to the control arm. So now, even within some countries, I can speak specifically for Nigeria, hydrochloroquine is not indicated as a treatment or to be used for COVID-19 management unless it is done under a research setting. And so there is still some ongoing large-scale research regarding the use of hydrochloroquine, but as it stands now, the evidence makes it a fiction.
All right. So another true or false question for you, Dr. Gray.
Okay.
COVID-19 cannot be transmitted to another person after 14 days of infection, true or false?
I will say I would like to be in the region of uncertain. Don't forget that after infection, you can be reinfected after the infection. So the evidence is pointing towards that now, that reinfection is possible even in an individual that has been earlier been infected and has probably recovered. Such individuals can be reinfected and they can also still spread or transmit the virus. So the general social distancing and basic health promotion and protective measures should take place. So whether you have recovered or not, you have to ensure you keep a distance of 1 meter, put on your face mask when you are, if you can't stay at home and you are outdoors, put on your face mask, keep a 1 meter distance at least, wash your hands as much as you can, especially after touching surfaces that can be or could be infected with the virus. And above all, if you do show symptoms, then you need to really present to the hospital or call your healthcare worker. So all those are more helpful than basing it on the fact that an individual has been infected before.
All right.
Yeah, may I add to that? Basically, the general rule is after your symptoms have disappeared, wait for 14 days and then you're safe. You won't infect other people. That's the general rule. 14 days after disappearance of symptoms.
Okay, thank you. So, Prof, how long will it take for the WHO to conclude investigations on the exact origin of the coronavirus?
Well, I mean, that's the same story for HIV. It's very interesting. To be honest, I liked that a lot. I was very interested in the origin of HIV, and the question is, does it help to know? Maybe you can point fingers at somebody. Does it help? I'm not sure. So what I know from, like was Dr. Greg also was saying, if you look at the sequences of the virus, then you can trace the sequences are mutating over time. So the virus population gets more and more mutated over time. So if you take a representative sample of the virus population and you calculate backwards, then you know where the original virus was and what was its DNA or RNA sequence. And that comes back to the bat. And like what Dr. Greg said, the virus is 96.2% identical to coronavirus from the bat in the horseshoe bat in China. And that bat is mostly likely infecting a pangolin. We're not completely sure. And those are eaten in the Chinese populations a lot. And so, it is the most likely trajectory. To be honest, we live in one connected world. I don't care where the virus comes from, because we see now wherever it comes from, it will spread all over the world in a couple of months, because everybody is connected. So I rather would like to say health is global nowadays. A healthy African means a healthy European, means a healthy American, means a healthy Australian, a healthy Asian. We're all connected. And I hope somehow that this epidemic makes us realize this, so that we put equal investments in fighting epidemics in Africa as we do in fighting epidemics in Europe. That's what we should do. This is politics, but okay.
Yeah, a lot of politics. Okay, so for time's sake, we'll take 5 more and then we'll call it a day. But just to inform everyone that keep asking your questions. We would share the questions with the panelists after we wrap up, and then we'll send the answers to you, as well as the slides via email. Okay, so again, Professor Tobias, what is the role of steroid in COVID-19?
Steroids in COVID-19. Okay, well, steroids are immune suppressors, and we know that the second stage of the disease is an overreaction of the immune system. So if you suppress the immune system to overreact, then symptoms go down. So in principle, steroids are good in the second stage of the disease, in principle. However, in the first stage of the disease, the first 1 or 2 weeks, then the immune system should be as strong as possible, because then the virus is there. So then steroids are not good. So the problem is that you basically need most likely a combination pill, like for AIDS, which combines antiviral activity and anti-inflammation activity in one single pill. And that the ratio between those two might be quite delicate and also maybe even person dependent. It is not a simple drug that we have to develop here, unfortunately. It is a combination drug with unknown dynamics over time. It will need work, serious work.
Thank you. So, Dr. Greg, what are the medical or traditional intakes, if there are, that can support and boost the immune system to enhance survival rates in the event that one eventually gets the virus?
But that's another interesting question, and I must say again that evidence is not showing any right now, other than what is necessary to maintain standard health and care of ourselves. And the normal micronutrients that we do take, vitamins, zinc, yes, they can help boost our immunity, but there is no evidence to show that they can be used for treatment. There is no evidence other than what they are currently being used for. So eat healthy so that you can get enough of these micronutrients into our system. And I want to believe that this question is probably tilting towards herbal treatments. And because the mention of the word traditional probably means herbal, and as it stands, no herbal treatment has been shown to be useful in the treatment of COVID-19.
Okay. All right, so there's someone here who probably doesn't sound very happy with when you said garlic, ginger, and vitamin C can cure the COVID-19 virus. This person believes you are making people lose hope other than giving them hope. The person thinks you should rather advise people to continue practicing safety acts and boost their immunity system by vitamin C intake, vegetables and fruits, etc.
Yes, thank you, Peggy, and thanks to that individual who has expressed this sadness. Yes, most of our beliefs that we have held dear due to cultural or different ideologies may have to be dashed by scientific evidence. And though it's my role to probably encourage us to be hopeful, but it's also my responsibility to provide the right information. And I prefer to err in the right of accurate, valid information than to give hope that probably may not be useful or helpful to us. So yes, like I've said earlier, the usual intake, our drive towards making sure we ensure that micronutrients in our diets, the different sources of micronutrients like that we usually take, please do go on. If it's these are shown to be helpful in building our immune system and helping us anti-inflammation and so on. We know that. So please do go on with that, but not for treatment, not for cure. If you have symptoms of COVID-19, please present to the hospital. These modalities cannot cure for now.
All right, thanks. So the last two questions are directed at Professor Tobias. And this person is asking where patient zero is and why is it so important to get hold of patient zero? Do you know where patient zero is, sir?
Well, I presented it. There is a patient zero in China reported in November, a 55-year-old man. It is, if that really is patient zero, then we might find the source, the intermediate host, because by interrogating that person, you might find out what he did, what he ate, where did he go, which markets did he visit. Maybe he indeed did eat a pangolin, for example. So it could give evidence of what is the intermediate host bringing the virus to us. And if you know that, then you can take better protection measures. So that would be indeed the advantage of knowing who is patient zero.
Okay, so the final question before we wrap up. Professor Tobias, you mentioned 19-day shedding period for asymptomatics.
Yeah.
That is quite a contradicting information to what we have in Nigeria, where this person is made to understand that shedding stops at day 10 in asymptomatics. This person happens to be a clinician and would like to have an ideal information to guide his patients as well as to help prevent the spread.
Yeah, shedding is a very, it's a diverse topic. And it might also be that, and we know also now that shedding is dependent also on mutations and on geographic areas even. The message basically is that shedding, when you get infected, it takes 4 or 5 days, let's say 5 days before you develop symptoms, if you develop symptoms. Shedding starts 1 or 2 days before this already. We also know that after the symptoms have disappeared, shedding continues still a couple of days. There are quite some papers on this. In other words, shedding takes a longer time period than the so-called clinical disease periods, obviously, before as well as after. For people who don't have any clinical symptoms, like the asymptomatics, we see a similar shedding period, approximately 3 weeks. So, in other words, shedding is a very widespread and normal phenomenon, whether you have symptoms or not. It takes approximately 3 weeks per person, unfortunately, but this is the most recent information.
Thank you, Professor Tobias. Thank you, Dr. Greg. And thank you everyone for joining. Unfortunately, this is the much we can take because of time. And will, however, like I mentioned earlier, send you the resources to this webinar as well as answers to all the questions asked via email. I'd like to encourage us to check our social media handles so that you can keep up to date with planned events and webinars as this. On Twitter is at PharmAccessNG, that's PharmAccess. On Instagram is at PharmAccess Group. On Facebook is PharmAccess Foundation. And our website is www.pharmaccess.org. Thank you once again for joining. Do enjoy the rest of your day and stay safe. Bye-bye.
Bye.
Bye-bye. Thank you.
Thank you.